Okay, we've already talked about amplitude, period, and phase shift. Now we're going to look at some other characteristics of sine and cosine functions. And really quick, just want to point out what I've done here. I have written a sample function, 2 cosine of 4 pi x minus 3, that we're going to use as we go through these. I've also, since I chose a cosine function for my example, I did a sketch of what a normal cosine graph would look like. This is just regular old cosine of x. So we're going to refer to both of those. And before we move on here, I just want to run through my sample equation and point out what is what. The 2 is obviously going to be the a, and that's what's going to determine the amplitude. So we've already talked about that. The 4 pi, that's what's being multiplied by the variable. So 4 pi is the b. And let's make a note of this. For my sample here, a is 2. My b, what's being multiplied by the x, is 4 pi. C is what is being added or subtracted to the variable inside the sine or cosine function. I don't have a c. So technically C would be 0, but I just don't have one for this example I've come up with because the C is not going to affect what we're talking about anyway. And then D is whatever is outside of the sine or the cosine that's added on or subtracted. And here the D is minus 3 or negative 3. And that number in this function, it's at the end, but sometimes it could also be at the beginning. So you could just easily write this negative 3 plus 2 cosine 4 pi of x. So sometimes this number right here is at the end. Sometimes it's at the beginning. It could really go in either place. So keep that in mind. All right. So the first thing we'll talk about is that last number. In our formula up here, it's d, and that's our vertical shift. And that's something you've already dealt with without really calling it the vertical shift. Whenever you add or subtract a number to any kind of function, including a sine or cosine function, it just moves your graph up and down. So your standard sine of x or cosine of x graph, the middle of the wave is going to be on the x-axis. And when you add or subtract a number, it's going to move the middle of the wave up or down that many places. So that's your vertical shift. Next is your maximum. So the maximum is the highest point of a sine or a cosine wave. And when you graph these, you notice it keeps returning to that maximum point on a periodic basis. It keeps going up to that same maximum point. So how do we find that? If we don't just have plain old sine x or cosine x, we've got a little more complicated function. How do we find that maximum without graphing it, just using the numbers we're given? And this is how you can think through it. First, on our sample here, 2 cosine 4 pi of x minus 3, think about the amplitude. Our amplitude here is 2. So I'm just going to graph a cosine function with an amplitude of 2 that still hasn't been shifted at all. So if this had an amplitude of 2, it would mean it would go up to 2 and down to negative 2. So it would get twice as high, twice as low. It's not the prettiest graph, but you get the point. It goes up to 2, down to negative 2. But this, my sample here, I have shifted it. I have a minus 3, so everything is going to move down 3 spots. So I was up at positive 2. When I shift it down 3 spots, my high point is going to be at negative 1. My low point here was at negative 2. If I go down 3 spots, now I'm going to be at negative 5. So my graph will shift down here, and it will look something like this. And this is a very rough sketch, so please be generous with me there. But that's how you can find the maximum and the minimum points. You have to think, what is the amplitude doing to stretch it vertically, and then how am I shifting it up and down? And the way this will always work is you take that vertical shift number d, which in this case is negative 3, because that is going to tell you how far you lower or raise all the points on the graph, and then you add the amplitude, which is the absolute value of A, which is that very first number you're multiplying by the sine or the cosine. In this case, that would be 2. So if you do -3 plus 2, that tells you on the graph of this function, the maximum point would be at -1. So that's a y value. Y would be -1 at the maximum point on that wave. The minimum works kind of the same way. You take your vertical shift number, -3, and this time you're going to subtract the amplitude. So subtract the absolute value of that number before sine or cosine. So here, if you have -3 and you subtract 2 from it, you're going to end up down at -5. And we can see in my very rough sketch of this graph that is the maximum and minimum. The maximum is -1. The minimum is -5. The other thing we're going to talk about is frequency. So we've talked about period, which is very helpful when we're making a graph. It tells us how long it takes for the function to run through one cycle. And that's very helpful when we're identifying points like on the x-axis and trying to sketch a graph. But what's probably more useful when we're doing, say, word problems is this other measure, which is frequency. And that's the number of periods in one unit. So for a standard sine or cosine graph, that's going to be like a weird fraction with pi in it because it does not complete a cycle before you get to 1. But in word problems, that's something that's going to be very helpful to find out. And you'll see that in a second, and it'll make more sense. But the frequency is the reciprocal of the period. So period, we know period is 2 pi over b, 2 pi over the number being multiplied by the variable. The frequency, you flip that. It's b over 2 pi. So if you look at our function up here, b is 4 pi. So to find the frequency, we would take 4 pi and we would divide it by 2 pi. And when we do that, the pi's cancel out. We get 4 over 2, which is just 2. So what that means is that this function, the graph of this function, would run through 2 full cycles before it got to 1, or by the time it got to 1. So that's how you find frequency. It's b over 2 pi. So let's do some quick examples, and then we'll do some word problems. So we got two equations here where it says to find the maximum, the minimum, and the frequency. So for number 1, our maximum, we take that vertical shift number, which is the +9, and we were going to add the amplitude, which is 4. And the maximum is going to be 13. That would have a maximum at 13. The minimum, we're going to take the same 2 numbers, but this time we're going to subtract. We're going to take the vertical shift of 9 minus the amplitude, which is 4, and we're going to get 5. So the graph of this would go up to 13, down to 5, up to 13, down to 5. To find the frequency, we are going to take the number multiplied by the variable, that's b, and it's going to be that number over 2 pi. So remember, frequency is b over 2 pi. So we're working with 8 pi. So it's going to be 8 pi over 2 pi. And when we simplify this, we end up with a frequency of 4. So our frequency is 4, our maximum is 13, our minimum is 5. Okay, let's look at number 2. So our maximum for number 2, we're going to start with -20. Everything in this graph has been shifted down 20. Then we're going to add the amplitude. Now remember, amplitude is an absolute value. So even though this says -50, the amplitude is +50. You always take the absolute value of this number to find your amplitude. So it's -20 plus +50, which will give you 30. So the maximum point here is 30. To do your minimum, again, you start with -20. This time you will subtract the 50, and you will be at -70. So this graph would oscillate up and down between +30 and -70. For our frequency, we're going to take b, which is pi over 3. That's what's being multiplied by the x, is pi over 3. And we're going to divide that by 2 pi. And so the way I work with anytime I have a fraction over a fraction, I split that into two fractions. So I'm going to make it pi over 3 times let's just go ahead and write this as divided by 2 pi over 1. Then I flip the second fraction and multiply. So this is going to become pi over 3 times 1 over 2 pi. And you can probably do that in fewer steps, but that's just how I think through it in my head. I make it into two fractions, flip the second fraction, and then multiply. When I do that, my pi's cancel out, and I get 1/6. So this would only run through 1/6 of its cycle by the time it got to 1 on the x-axis. So that's my frequency. Okay, so that's maximum, minimum, and frequency. And like I said, the main way we want to use this is with word problems. So we're going to do a few things with this situation with a Ferris wheel. So it says the height of the seat on the Ferris wheel. So you sit on your seat in the little car on the Ferris wheel, and that seat is at a certain height. And once the Ferris wheel starts, the height's going to change because you're going to be going up and then around and then down again. And so it's modeled by this function right here. So t is our variable, and t is the number of seconds after that Ferris wheel starts. So if you wanted to, you could use this function to figure out how high in the air you will be at any point along that ride. So the first thing it asks us to do here is find the maximum and minimum height of that seat you are sitting on. So our maximum, we're going to start with our vertical shift number, which is 35. That's what's being added onto the end. And we are going to add the amplitude. Now remember, we got to take an absolute value of -30 to find our amplitude. So we're going to add 30 to the 35. And so the maximum height of that seat on the Ferris wheel is going to be 65 feet. So 65 feet up in the air is the highest you will go on this particular Ferris wheel. To find the low point, the minimum, what you're going to do is take the same two numbers and subtract. So you'll take 35 minus 30. And you will find when you first get on the ride at the bottom, you will be 5 feet off the ground when you sit down at the beginning of the ride. So you will be between 5 feet and 65 feet as you go around that Ferris wheel. All right, next thing with the Ferris wheel, it asks us to find the period of the function. And what does the period represent? So remember, period is 2 pi over b. And b in this case is whatever's multiplied by the variable. So it's pi over 20. So to find our period, we're going to take 2 pi over pi over 20. And as I like to do, I'm going to make this 2 pi over 1 divided by pi over 20. I'm going to flip the second fraction. I will have 2 pi over 1 times 20 over pi. The pi's cancel out, and I will get 40. So the question is, 40 is our period. What does that represent? And so our period is how long or how far along on the x-axis does it take for our function to run through one full cycle. So for a Ferris wheel, one full cycle is how long does it take that Ferris wheel to go all the way around. So in this case, our answer is 40. So it's 40 seconds for one full rotation of that Ferris wheel, or one full cycle. So that Ferris wheel in 40 seconds, you will go, say, from the bottom all the way to the top and then back around to the bottom. So it's a 40-second period to run its full course. Okay, next question with the Ferris wheel is the height again is modeled by this, and we found the maximum and minimum. But what we want to know is at 20 seconds into the ride, 20 seconds after we start, how high will we be? So for our particular seat on the Ferris wheel, which is modeled by this function, how high will we be after 20 seconds? And so this doesn't ask us to find the amplitude, the period, the phase shift, the frequency, the maximum, the minimum. This just asks us to plug in a number for our variable. So what we're going to do is we're going to say negative 30 cosine of pi over 20 times t, which in this case is 20. We're plugging 20 in for t, and then plus 35. The nice thing about this is the 20s cancel out. So we have negative 30 cosine of pi plus 35. Now you can think back to your unit circle. What is cosine of pi? Well, I'm going to do very quick unit circle here. And I know that this is 0 right here. Pi is halfway around. Pi is over here. So if I'm at this point, this is negative 1, 0. And my cosine is always the x value. So you can plug that into a calculator. You can put that in the Google search bar. Just ask what's cosine of pi, and it'll give it to you. But I think that's an important one to know, that cosine of pi is negative 1. So I'm going to have negative 30 times cosine of pi, which is negative 1 plus 35. And when I work out this expression here, the negative 30 times negative 1 becomes positive 30 plus 35. And I find that after 20 seconds, I am at 65 feet. So I'm actually at my maximum height. So keep that in mind. These are functions. You can, like any other function, plug in something for the variable, work it out. And in the case of a word problem, it should tell you something meaningful about the situation. In this case, how high up you are after a certain amount of time. All right, let's shift gears here. No more Ferris wheel. This time we have a tuning fork. So a tuning fork, and you don't really need tuning forks anymore because we have like digital tuners. But it operates by the same principle. It creates a frequency. And by frequency, we mean a vibration. And the frequency is how many vibrations per second there are, because different numbers of vibrations create different pitches, which is very important in music. So the question here is, if this vibration of this tuning fork is represented by this function here, what is the frequency of the tuning fork? And frequency in word problems is often going to be how many times per second or per minute or per some other unit of time. So in this one, it's per second. So what we want to do is find the frequency. So frequency is the reciprocal of period. It is b over 2 pi. And b is always our number that we're multiplying by the variable. So b is 256 pi. So our frequency, we'll take 256 pi. We will divide it by 2 pi. Our pi's cancel out, and then we can divide 256 by 2. You will get 128. And so it's 128 vibrations per second. It's the frequency here. And that's vibrations per second, or the number of times it does something per second, can also be represented by hertz, which we're not really going to talk too much about. The important thing is that you get the 128 number, that it would vibrate 128 times per second. So hopefully this takes this very abstract stuff we've been doing and makes it a little more grounded, connects it to some real actual things. And there's obviously more we could do with this, but right now I want to really make sure we can calculate maximums, minimums, and frequencies, and also just be able to answer word problems where we would have to plug in a value or find something we already know, like the amplitude or the period. So there you go.